Well, good morning, good afternoon, good evening to everyone, wherever you may be across this lovely world. It's now 2023. Can you imagine it? Well, thanks for joining us live here today for Serverless Office Hours, streaming on the AWS Twitch channel and also on YouTube Serverless Land and also on LinkedIn Live. My name's Julian Wood. I'm a senior developer advocate for Serverless at AWS, and I'm joined by the fantastic, of course, Mr. James Eastman. James, how are you today?
I am doing well, Julian. I might have to stop and pause and cough a few times during this hour, but yeah, aside from getting over the Christmas illness that seems to be going around, yeah, I'm doing well, thank you.
Oh, good. Well, yeah, cough ahead. It's been going around everywhere. So, yeah, this is live, so you can see we're not going to edit out all the coughs. We're in different places at the moment. We're not in the same country, so we are, coming across to you live. Also, remember this is live, so please send us your questions, your comments. Tell us where you're coming from, your exciting things you're doing with Serverless in 2023. Anything and everything, and we'll try and answer your questions or talk about your comments. So, just before I introduce James again, we're going to head back looking over the past few weeks of AWS Serverless, pretty much sort of on the countdown to the end of last year. The last show we had was on December the 19th, and talking about the new functionality with step functions about doing large-scale parallel data processing. And James spoke to Brian and Denise, and that was a really good show to show how you can basically put loads of files into S3 and process them very quickly and very efficiently using the awesome step functions. So have a look at that. All the past episodes are on Serverless Land on YouTube. So that's the place to go to have a look. In terms of what's new in AWS Serverless, even though over the holidays times people aren't not doing anything, some interesting things have been coming out to do with Lambda. The AWS migration hub has got some new sort of enables AWS Lambda aliases as service endpoints, and there are some blog posts and information about that as well. If you are doing Kinesis for all sort of video streaming, well, that also allows you to now use WebRTC for that as well. And then two really important things, which I think are going to touch a lot of people for Amazon S3. The really important one is S3 is now automatically going to encrypt all new objects. Can't quite remember the date offhand, but I think that's going to be April, maybe May. But yeah, just another well-architected thing of building in the cloud. S3 objects are automatically now going to be encrypted. Obviously, S3 has always been encrypted, but now they're automatically going to be done, and you can pick whether you're going to use an AWS key or your own keys, and just makes it a whole bunch easier. And also, Amazon S3 keeps going on, and some tiered pricing for cost-effective monitoring at scale. So that's all good to know. In terms of blog posts coming out, a bit of a wrap up over last year, which Masha on my team has done. So in case you missed it, that's what the ICMI is for Q4 2022 is up there. And that covers a whole bunch of things that has been happening at reInvent, releases and talks and all those kind of things, and certainly worth taking a look. Now, just talking about reInvent, yes, so many great content out on YouTube. If you look on Serverless Land as well, serverlessland.com, I'll post a link to that later. There's a playlist on YouTube as well, and on the website there are hundreds and hundreds of reInvent talks which are up. Obviously lots of serverless ones, lots of everything, so if you're connecting anything or doing anything with AWS, some really good quality content to be able to pass the time and catch up with what's going on. But today we're talking about all the exciting things with .NET and high performance Lambda functions with .NET. And of course, we need to have the excellent James Eastman on because he's one of our .NET experts at AWS. So James, well, welcome back again to Serverless Office Hours. Have you been up to anything exciting since we last spoke, or is this just your head is recovering from your cold?
Yeah, I think it was pre-reInvent actually, because it was my first reInvent actually last year.
Yeah, and we met in person as well, which
We did
sounds weird.
indeed.
You think we all know each other and live next door, but actually, meeting all your colleagues on the other side of the world is great as well.
Yeah, it was, but I had a couple of days after reInvent to kind of decompress in the US. But I don't know. I feel like the end of my year last year just kind of disappeared somewhere. I don't really know where, but
I know there is a bit of downtime where people just sort of relax and everything, but there are a whole bunch of releases coming out which have been working. So
yeah.
AWS is never busy. That's surely. So yeah, James, what can you tell us about .NET 7 on Lambda? That sounds like a very broad question, but over to you.
Yeah, absolutely. So where I actually wanted to start is to talk about how Lambda supports runtimes, because .NET 7 isn't a LTS release from Microsoft, right? So Microsoft have committed to releasing a new version of .NET every
So
year.
if just for acronym soup for people, that's long-term service release. So this
Yeah,
is Microsoft is going to determine some releases are going to be supported for a longer time than others, and
yep,
.NET 7 is not a long-term release.
correct. So they've committed that every other release will be a long term support release. That is falling on the even numbers for ease of remembering. So .NET 7 isn't actually going to be a long-term support release. So what that means from a Lambda perspective is that Lambda across the board, this isn't just for .NET, but doesn't ordinarily support LTS releases, right? Yeah. So there won't be a built-in managed runtime for .NET 7. But so what I want to start is to kind of just, before we get into the high performance stuff really, is just to talk about how you can use .NET 7 as it is on Lambda, because you can do that today using custom runtimes. So if you could just bob my screen up, Julian, unless it's already up. I don't think it is.
Sorry, James, I think I hit a USB cable or something went weird. I said we're live streaming, this is what happens. So I won't touch anything.
Yeah, could you bob my screen up, please?
Yes, I certainly can.
Absolutely. Awesome. So outside of the managed runtimes in Lambda, there's a couple of other ways you can run code in Lambda. The first is a container image. I'll come back to that in just a second. But the second and the more interesting one for .NET 7 at least is using what we call custom runtimes. And a custom runtime allows you to run almost any application code, I guess, Julian, on Lambda, really. With the key thing being that what the custom runtime will do is it will look for a file named Bootstrap. Now that's the really important thing when you start using custom runtimes. In the zip file that you send up to Lambda needs to have a file called Bootstrap in it, and that file needs to be executable. Now we can use this with .NET to actually to run .NET 7 on Lambda, and the tooling, the AWS Lambda tooling for .NET provides ways to make this nice and easy. So if I just flick over to my code editor now, so this, what we're looking at here is not necessarily a high performance Lambda function. This is just .NET 7 running in Lambda. And the really important thing I'll point out just to start is that we are actually compiling this assembly with the name Bootstrap. You can see that just there. So when we actually push out this, compile this .NET code and push that up to Lambda, the executable file that goes up to Lambda will be called Bootstrap. That means we can run .NET 7 on Lambda right now. We can do that today.
Yeah, and I know some people sort of worry a bit about a custom runtime and think, oh, because it's custom, it's somehow not as robust or something as a managed Lambda runtime. And the fact is, a managed Lambda runtime and a custom runtime uses the exact same API within the Lambda service to communicate. The custom runtime, yes, you are providing some of your own code to be able to interact with that API, but you are still taking advantage of all Lambda's availability, scalability, security, everything under the hood. And the Bootstrap file, as James is talking about, is actually quite a small thing. And it allows you to bring, as James said, any runtime to Lambda. So things like Go and Rust and any compiled languages, it's actually preferable to use a custom runtime. For instance, example like Go version 2 isn't a managed runtime for Lambda because the Lambda team is like, there's no point doing a managed runtime. You're going to compile a binary, Go binary, and so it's actually as easy and as simple to use a custom runtime in the compiled binary example as a managed runtime. So if you hear the word custom runtime, it doesn't mean it's a hacky attempt to do anything. It's using the exact same API. You're just adding some boilerplate code to talk to that API, but otherwise Lambda works as it does with a managed runtime.
Yeah, I think something I'll add to that as well. One of the common things I hear with custom runtimes is that the patching conversation, right? But the underlying infrastructure behind Lambda is still patched in the same way, exactly the same. The only reason patching maybe comes into the conversation is if a new version of .NET 7 gets released. Then, of course, you would need to recompile, re-upload your code, and you'd need to do that. But the underlying infrastructure behind Lambda is still patched in the same way.
Yeah, that's a good point, because all of Lambda is running on Amazon Linux or Amazon Linux 2, and under the hood, that's all going to get patched. And so, yeah, there's a differentiation between what AWS and particularly Lambda is going to look after, all the operating system patching, all of those kind of things, and then your custom code, which is going to be your .NET stuff, is going to be a compiled binary. But because it's compiled, well, you sort of have a responsibility to look after that code anyway.
Yeah, absolutely. So what that actually looks like from a .NET perspective, so any .NET developers listening or watching will probably be quite familiar with this method here. For anyone who isn't, if you're building a .NET application and you create a static method called main, That's what .NET will use as the entry point of your application, if you will. So this private static method here, that is what, when that bootstrap binary gets executed, this is going to be the entry point for the code, these lines of code here. And all we're doing in these lines of code here is we're just bootstrapping what's called the Lambda. We're bootstrapping the Lambda runtime in essence, and we're doing that using the runtime APIs. And as Julian kind of said, this is much the same way that Lambda works anyway. We're just taking that code that's hidden away behind the scenes within the managed runtime, and we're just bringing that into the forefront. So what we're doing here, and this Lambda bootstrap builder object here is provided by this Amazon Lambda runtime support package. You can get that on NuGet in your package manager, and that provides these additional things you can use to actually bootstrap the runtime. So what we do is we bootstrap the runtime, and we actually pass in the handler, the handling method that we want to use to handle requests. And then we also need to pass in a JSON serializer that Lambda's going to use to take that inbound request payload and then deserialize that into an actual strongly typed .NET object. We set this up and we run this, and this Lambda function in its execution environment is now ready to receive requests. Now, if we go down and look at the actual function handler itself, this is much the same as any .NET handler you would see if you're using a managed runtime. You've got your input object here. In this case, it's coming from API gateway. We've got our Lambda context, and then the application code is much the same as it was. So the reason I've pointed this out to begin with is some of this stuff is relevant for the high performance stuff we'll get on into in a second, but it's also, if there's a really convincing reason for you to start using .NET 7, maybe it's a new feature that Microsoft have released, you can do that right now, today. You could do that on release on November the 17th, I think it was, when .NET 7 went GA. You could do that straight away. That was ready to go. So that is .NET 7 and how you can use .NET 7 on Lambda. Now, what I want to actually get on and talk about with the high performance stuff is one of the features that went generally available in .NET 7, and I kind of touched on this last time I was on, Julian, and this is native AOT. For anyone who didn't catch the last time I was on here, native AOT is a new feature that's come to .NET that when you compile your .NET application, it compiles that down to a native binary. It compiles that down to machine code, and it performs quite a aggressive trim against your application to trim out any code that isn't used. So what that gives you is a relatively small binary that is already optimized for the given OS and processor architecture that it's going to run on. So it turns .NET into a bit like Go in some respects, in that Go is just a native binary, kind of what you were saying, Julian. The reason they're not supporting Go 2 is because it's just a binary. It can run anywhere. And the same is true for native AOT with .NET 7. Now, the way we used to do this previously, if I just open up another code sample now. So when I was last on and we talked about this with .NET 6, you had to kind of do some weird Docker. You had to create a Docker file, and you had to run some custom deployment script to create a custom Docker image and pull that down and compile your code. And it was kind of a little bit convoluted. So what we've done for .NET 7 is we've added some additional functionalities to some of the .NET tooling and to AWS SAM to abstract away some of the complexities of compiling .NET 7 and native AOT, so you can just compile your application as you would normally. One thing I forgot to mention then is with native AOT, the code has to be compiled on the same OS and processor architecture as the code is going to run on. So that means because we're packaging up and deploying our code onto Amazon Linux 2, which is what is behind Lambda, we need to actually compile our code on Amazon Linux 2. And I don't imagine there's many people listening, Julian, who are running Amazon Linux 2 as their day-to-day dev machine. There might be some out there, but I don't imagine there's too many. So this is why we needed, with .NET 6, and before we released our new tooling, we needed this functionality to create a Docker file and do all this kind of weird management. So I'm going to flip over to another code sample now, which is this .NET. Actually, before we do that, let's go somewhere else. So what we have created is I just create a new directory here, call that .NET 7. So within the .NET CLI tooling that AWS provide for dealing with Lambda functions, we've added a new set of templates for using native AOT. So if I run a .NET new now, and I can do .NET new list Lambda, and this will show me all of the templates available for AWS Lambda. You see, I've got this lambda.native AOT option, and this is a pre-built template that you can use to get started with native AOT on Lambda. The same also applies for AWS SAM. If you're an AWS SAM fan, much like I am, there's also templates. If I just quickly go through this wizard, you see number one on the list. Would you look at that? Number one on the list, AOT.
Who do you know? Who do you know that you're bribing to get top of the list?
I'm going to guess it's alphabetical.
Exactly,
but I'll claim that one. So yeah, there's pre-built templates in SAM and in the .NET tooling.
And in fact, if you just look down that list, you can see numbers 7 and 8 for GraalVM. GraalVM is a native compiled binary for Java. Rust is a native controlled binary for obviously Rust. And you can see they're all using the provider.al2. That's the Amazon Linux 2 custom runtime. So, and Go as well. You can see there Go number 6. So you can see quite a few of these runtimes when it is a compiled binary using the custom runtime.
Yeah, absolutely. So what I will do now is I'm going to actually use the .NET tooling to create a new Lambda function. So if I do .NET new Lambda native AOT, and we'll just call that 7 native AOT. This will create me a new template. And if I open this template up in my IDE, and we'll just get right through to the actual directory with the code in. This code will look exactly like almost exactly like the one we just looked at for just pure .NET 7. You see, we've got this static main method that's going to be the entry point of the application. We're setting up the Lambda runtime to be able to receive requests. We're passing in our handler. And then this sample here just does a simple two-upper. Go away, Visual Studio. We'll open just as a simple two-upper on the string that gets passed in. So the reason I started with that .NET 7 example is because it's very, very similar if you're using .NET 7 or you're doing native AOT. What's different, I hear you ask? So if I go off to my actual project file, the one we were looking at earlier, so there's a couple of things in here that are relevant. The first one being, as we looked at last time, the assembly name needs to be Bootstrap. That is a requirement of using the custom runtime on Lambda. And then the other thing we've got is this publish AOT property. Now, this is nothing AWS related. This is something Microsoft have added in that when I add that publish AOT true property to my .NET project, that will then tell the .NET compiler to actually do a native AOT compilation instead of just doing a standard compilation. So they're the things you would need to change in your project file to enable, to turn on native AOT compilation, if you will, and then the Bootstrap assembly name.
Is there any reason you wouldn't turn on native AOT?
Yes, absolutely. I will come to that. Yeah, there's certainly some drawbacks with native AOT. Yeah, I'll come back to them.
But is the native AOT, is this just for creating the Bootstrap or for the whole project? Or is it because it's a compiled binary, it's all in one thing anyway, that there's no distinction between the two sort of components?
Yeah, absolutely. So if I, I've got a single Lambda function here. If I add 5 Lambda functions, that would be 5 separate projects. So you need to turn AOT on in the 5 separate project files, and they would then compile into 5 separate binaries that would then go out to be 5 separate Lambda functions, if that makes sense.
Okay, yeah.
You could, if you were looking at kind of Lambda lif-esque stuff, you could do a single binary, upload that to different Lambda functions. But yeah, you would do this in each of your separate projects. So what will actually happen, and I'm going to come back to the code sample in a slightly more built out example, but I wanted to use a brand new project just to kind of demonstrate how the deployment works. So now that I've created this project, if I now run a .NET Lambda deploy function, and this works exactly the same if you run a SAM build, because under the hood, SAM build for a .NET application runs .NET Lambda deploy function. So the SAM uses this same tooling, which is why I'm starting at this bottom level. And what will happen when I run this .NET Lambda deploy function, and a prerequisite to this is having Docker installed and running on your machine. You can see there what's actually going to happen is that the AWS tooling, the CLI, is actually going to pull down a Docker image. I happen to already have that Docker image on my machine. It's the same build image that Sam uses. And then it's actually going to compile my application inside of that running Docker container, that Docker container running Amazon Linux 2. So all that compilation is now happening, as far as the compiler is concerned, within Amazon Linux 2 on an Amazon Linux 2 machine. What this has also done is actually connected my local file system to that running Docker container, which means once these files are compiled, it will then spit these the compiled zip file back out to my local machine, and the deployment can then happen from there. I'm trying to talk really slowly because native AOT does take a little bit of time to compile. So coming back to your question on potential drawbacks, Julian, the speed of compilation is one of them. It does take
Well, I
longer.
suppose it's got to do that minimization effort. It's got to go through all the class libraries and decide what it needs to keep and remove. So
yeah, absolutely. And you can kind of see that happening here. So it's actually compiled the actual the DLL quite quickly, the output DLL quite quickly, and then it started generating the native code. And this is where the time seems to be.
Okay. Would there be a distinction in a development workflow that you wouldn't put on AOT just to have a fast feedback loop for testing your function code and then turning on AOT for your deployment, or does that mess up other things?
So if you were going to test, if you were to run, for example, we have a test tool, a .NET Lambda test tool that builds your code in debug mode. If I was just to run a .NET build as opposed to a .NET publish, or try to start it locally, that AOT property will be ignored.
Okay.
So the AOT property kicks in. So with the .NET CLI, you've got a couple of different commands. So if you run a .NET build, that just does a standard compilation of the code. This will run in a couple of seconds, I imagine. Once I run a .NET publish, that's where the compiler goes, I've got publish AOT in there. Let's publish that. And
so in a way, you can still keep your local fast feedback loop, building .NET applications, and then when you deploy into Lambda, because you want to use the native AOT, off you go and use the native AOT, but it's not going to necessarily slow you down in your sort of iterative local fast feedback loop.
Yeah, absolutely. And if I was to the Amazon tooling that I ran there when I ran .NET Lambda deploy function, that's actually reading this project file. So if I was to get rid of that or conditionally show that publish AOT property, our tooling is smart enough to say, publish AOT is there, do it in a Docker container. Publish AOT is false or not there. Just do it as you would normally do it. So the tooling is kind of smart enough to make that distinction between whether to use publish AOT or not.
Yeah, and also the whole container concept, I know sometimes I come from a Windows background, that the whole sort of Docker and container thing can sometimes be a sort of another stretch, but it is so simple. And once you've got Docker installed, and it really allows you to have this, these separate build environments. It just pulls down the Docker container, does the build. As James says, it's got a sort of a pipe through to your local file system. You don't need to know anything about Docker. You don't need to do anything with that, and it's such a really simple way particularly on Windows, to be able to keep your development environment separate from each other, and you're not having to install a whole bunch of crazy stuff locally to do different kind of things. And even if you are then, for example, building Lambda functions using ARM Graviton 2, you've got an x86 machine, you can compile even for another processor architecture. So yeah, it gives you a lot of functionality, and it's not a barrier that should intimidate you in any way. The tooling with the .NET and tooling with SAM is really well integrated. That just works.
It seems like you're teeing me up for these, Julian, because you've teed me up for another one of the drawbacks there. We didn't discuss this beforehand, honest.
Not at all.
So one of the drawbacks with, and this is Amazon Linux 2 specific, not Lambda specific, but .NET 7 and ARM are not currently compatible. Yeah. That is something we're looking into. We're actively looking into getting that resolved, so you can use .NET 7 on ARM-based processor architectures. But as of right now, if you're using .NET 7 and native AOT, that will need to be on x86. That won't run on ARM today, but that's not to say it won't in the future. What's the next one we need to talk about, Julian? What is it you teaming up for?
What? Yeah, I don't know. We do have a just a question from Rathan. Thanks for joining us
Yep.
via YouTube. Could the native AOT template apply for serverless application API controllers? Not quite sure what that specifically is for API controllers.
So it could be referring to, and if he is, I'm going to get onto it. But Rathan, could you just confirm? Are you talking about you running ASP.NET and a full API within Lambda? If you could just pop a yes in, if that's what you're referring.
Is that something behind API gateway or function URLs or something like that? I suppose, yeah. Let us know what you're thinking and we can help.
Yeah. So if we look at a more complete example now, and this example here is on GitHub. It's in the serverless.NET demo repo we have for all the .NET benchmarks. And this is the example that is a bit more real world, should we say. So this is just an API that allows you to get and create and delete products.
So anyway, Rathan has come back with a yes, so yes. It is building an API. Yeah.
Yes, and I'm going to get onto that. I've got another example that shows just how you can do that. Yeah. That will be next, coming up shortly. So if we take a look at this more complete .NET 7 example now, and the reason I've switched over to this is just to demonstrate some of the other things that you need to think about when you're doing native ahead of time compilation. So as we talked about, this is a different project, but just to kind of demonstrate, we've got publish AOT set to true. We've got the assembly name set to bootstrap. Within our actual function code, there are a couple of other things that we need to think about. And I'm just going to build this code very quickly to get rid of all of them angry red lines. So a couple of the things that we need to think about. The first is JSON serialization and deserialization. So the de facto packages for doing serialization and serialization in .NET, which are Newtonsoft JSON and the system text JSON that's kind of built into the language, they both quite heavily use reflection for taking that JSON string and changing that into a strongly typed .NET object. Now, one of the other drawbacks of .NET 7 is some of these dynamic language features of .NET, like reflection, aren't supported. And if you think about that, the reason is if I've got a class in my project, if that class isn't used until runtime, when it's serialized or deserialized, the trimmer is just going to get rid of it. The trimmer is just going to trim that class out, which means my request will come in, the serialization will try and happen, and the class won't actually exist anymore. So there's some of these other things that you kind of lose when you use native AOT. However, Microsoft have got a way around that. And this actually went GA in .NET 6, and it's a feature called source-generated serialization. And what source-generated serialization does is it generates the code required for serialization and deserialization at compile time instead of at runtime. Now, this will potentially have a performance impact to your .NET 6 Lambda functions, right? Because reflection is typically quite a slow process. If you've got that code ready to do serialization at compile time, this may well help your .NET 6 applications as well as your .NET 7 applications. And how you define a source-generated serializer so this is something that you need to be using system text JSON for. So if you're using Newtonsoft for your serialization and deserialization, you won't be able to do this. You'll need to migrate to use system text JSON. And what you need to do is just create a new partial class in your project. And that class simply needs to inherit from this JSON serializer context. And then all you need to do is add all of these attributes for all of the different types in your project that you want to be serialized and deserialized. So in this case, of course, I've got my API gateway request and response objects that come from the Amazon Lambda API Gateway events package. And then I've also got a couple of custom types in my project, namely for products and the kind of wrapper around the products that gets returned by the API. And I've added all these as attributes to that partial class. And that's all I need to do to set up source-generated serialization. At compile time now, the compiler will take all of these types that are specified here and generate the necessary code to do that serialization and deserialization. So if you were to go and pull apart the binary and have a look inside it, you would see actual objects for doing this serialization and deserialization. In terms of, if I go back over to my function code now, so when we actually create this Lambda, when we set up the Lambda runtime ready to receive requests, we then need to pass that custom serialization context into our runtime to then do that serialization and deserialization of the payload that comes in. And we do that using this source generator Lambda JSON serialization. Words could have been named a lot better, I feel. They didn't think of us streamers, Julian, when they named that class. Source generator Lambda JSON serializer. There we are. Got it the second time. We create, and this package, this class comes from the Amazon Lambda serialization system text JSON package. So again, this is a package that AWS provides. You don't need to write that code yourself. You pass in that serializer, and then we pass in that custom JSON serializer context that we've just looked at as a type there. And then that will then tell the runtime for any requests that come in that need to be serialized or deserialized, use that source generated serialization instead of trying to use reflection or anything like that. Now that's like I said, that's something you can do in .NET 6. So that if you've got really low latency, high performance requirements in .NET 6 Lambda functions, it may well be worth looking into using source generated serialization for that, because it's all then generated at compile time. You're not relying on reflection and some of these slightly slower language features. The final thing to just touch on is around trimming. So when native AOT compilation happens, as well as generating machine code that's ready for Amazon Linux 2, it also quite extensively trims your application code. Now, because native AOT is so new, there's a whole bunch of libraries out there, packages out there, the AWS SDK being one of them, that aren't yet trim friendly. So almost the whole of the .NET ecosystem now needs to go through their libraries and make them trim friendly. That would cause us a challenge, because if we were to try and use native AOT without and the AWS SDK today, a whole bunch of required things just get trimmed straight out. Thankfully, Microsoft have provided a couple of ways around that potentially. The first is you can actually control how trimming happens. And you can use that using this trim mode property, and you can do that and set that trim mode to partial. As a default, that's set to full by default. So if you don't put it in at all, the trim mode set to full. Full trim mode just trims everything. Partial trim mode tells the compiler to first check if a given library is trim friendly. And if it isn't trim friendly, it won't trim it at all. If it is trim friendly, it will trim it. So that's quite a handy little property you can put in there. If I was to do that as it is, the compiler would trim things that can be trimmed and it would ignore things that can't. If you needed more fine-grained control over the trimming, we can leave the trim mode set to full. And we can then provide these list of trimmer root assemblies here in our project file. And this is where we're telling the compiler to, yeah, trim as much as you want, go wild. But actually, these six libraries I've defined here, don't trim them at all. And you can get even more specific. You can say this specific class in this specific namespace in this specific project. You can get really granular with these trimming options. If I just flick over to my browser window, if my browser hadn't just crashed, that is helpful. Yeah, so my browser's crashed everywhere, so let's hope you can still hear me.
We can.
Yeah, you can, cool. So yeah, if you could just pop that trimming options link into the chat, actually, Julian, that'd be awesome.
Yeah.
So yeah, there's a whole range of configuration options you've got to kind of control how the trimming happens, right down to quite a granular level. So that's the other thing you need to think about if you're using native AOT. One of the things you need to be quite careful of if you're thinking of using native AOT, and again, coming back to the drawbacks, the issues that you will get with trimming may not potentially happen at compile time. So if you're trying to trim an assembly that's not trim friendly, the compiler will give you a whole bunch of warnings. And as a general rule of thumb, if you're getting a warning from your compilation, there's a chance that that might cause issues at runtime. And there's two types of issues here. There's one, maybe that you might just get a runtime exception. So the AWS SDK, for example, it will let you compile, it will let you deploy, and then you'll try and use the SDK and it will fail at runtime. The other potential issue you might get is around the trimming of your classes, because the trimmer could potentially trim a property out of a class. Let's say your product object has got a name and a price and a description. The trimmer could well trim out the price property. You might then store that in a database, and then 6 months later you realize that the price has never been stored because the compiler has been trimming it out. So there's a couple of use cases you need to be really careful of if you're using native AOT. This is, native AOT is something supported by Microsoft. It's only supported with console apps currently. So all I'd suggest is if you are using native AOT, make sure you've got really good test coverage, both unit tests, integration tests. You're testing the data that gets to your database, because this trimming can cause some potential challenges with how that data gets formatted. Okay, so the final thing I wanted to discuss is exactly the question that Rithani asked. If I just find another code sample, and that is whether you can use native AOT with an actual ASP.NET application. Now, there's a huge disclaimer here I need to put in big bold letters, if we can do that, Julian, is Microsoft don't currently say that ASP.NET, which is the underlying framework that supports APIs in .NET, ASP.NET does not support native AOT. In .NET 7, that's not a thing. .NET 8, they're looking at it, it should be there in .NET 8, but in .NET 7, officially, Microsoft do not support APIs with native AOT. Now, that's not to say they don't work, however. So you can use native AOT with APIs, you can build and you can deploy them and they work. Just use with care. Like I said, Microsoft don't officially support them yet. They do work, though. So if you're looking at doing that on Lambda, so what we've got here is the same application we were just looking at. So it's an API to manage products, so to get products, delete products, create products, etc. And this is built using the .NET minimal API syntax. So all I'm doing here is defining my API endpoints. So I've got 4 API endpoints, and then I just pass in a handler. If I go down to my handlers now, you see I've actually got the actual code that's going to handle that request. So to set this up to run on Lambda, if I go over to my startup class over here, so AWS already provides tooling to run ASP.NET applications on Lambda, and that's using the Amazon Lambda ASP.NET Core Server and ASP.NET Core Server hosting NuGet packages. So these are packages that give you the capability just to take your existing ASP.NET API and throw that into Lambda. And to do that, all I do in my startup class of my application is just specify this add AWS Lambda hosting method. So to my dependency injection container, I'm adding AWS Lambda hosting. And then all I need to do is specify what's sat in front of my Lambda function. That could be API Gateway HTTP APIs, API Gateway REST APIs, or an application load balancer. And the setting you will use there is different based on what's in front of it. The reason that differs is that what this is doing behind the scenes is it's taking the inbound request from Lambda, the event payload, and it's translating that into a format that ASP.NET understands. Because the event payload is slightly different if you're using HTTP APIs or REST APIs or application load balancers, this is where we're just telling the package how to do that parse from one format to another, and then the same on the way back out. The second thing you can then do is you can pass in this option. You can configure some options against how this is going to work. And if you're using ASP.NET on Lambda today, you might need to update to the latest version. This is quite a new thing that I added to the package just before Christmas. So you might need to do an update to your package. But you can now set the serializer for this translation to use. So we're now telling that translation from the event payload serialized to a C# object, translated to ASP.NET. That's now going to use source-generated serializers, as you can imagine. So now that will set up the AWS Lambda hosting of this ASP.NET application to use source-generated serializers, which then enables native AOT because we can do that serialization and deserialization now. The other thing you'll need to add, and this isn't AWS specific, this is just .NET in general, when you configure your startup of your application, you can configure how ASP.NET handles JSON. And all I'm saying here is when you're handling JSON, just add this additional JSON serialization context so ASP.NET itself knows how to do serialization and deserialization. And this function will now run on Lambda. That's all we need to do to enable ASP.NET on Lambda. And one of the beauties of this AWS Lambda hosting method is that it's smart enough to know if I'm in Lambda or if I'm on my local machine. So if I was to just run this application locally now, it would actually start up locally, absolutely fine. The second I deploy it into Lambda, it knows that it's within Lambda. It knows that it's been deployed in that Lambda execution environment, and it will then start up slightly differently and be ready to handle them event payloads and then requests as they come in. So in terms of local debugging experience, things that we're all familiar with as .NET developers, this is a really nice way to still get that, as well as the scalability, performance, security, etc. that Lambda provides. So I know the name of this was highperformance.net. So what I thought I would do now is actually look at some of the performance numbers.
James, before we just get to the high performance, and I want to see this high performance stuff as much as anybody, we just have two questions that have come in. The Shazam26, thanks for joining us via YouTube. With native AOT, can you speak to the increased size of the compiled package and then the potential impact of having a bigger package on Lambda performance?
Yeah, so that's a really good question, actually. And what we found from our benchmarks is that the increased size of the package is offset by the speed of startup and the speed of the runtime initialization. So yes, the package is bigger, absolutely. But, and we'll get to that when we look at the benchmarks and we look at the numbers, that's kind of offset by the increased speed you get elsewhere.
And also the increased size of the compiled package, I mean, we're not talking about a huge amount of additional data here, I think. So literally first of all, for any asynchronous functions, any cold start startup time doesn't mean anything because it's going to be asynchronous anyway. So for a synchronous web request, I mean, we are talking such small numbers for the delta for an additional compiled package. And literally, because technically behind the scenes, what we actually do for a zip file archive package is pull that package down from S3 and load it into the Lambda execution environment. So we are talking about, if you've got a 30 meg package or a 32 meg package, if you timed the difference that it takes to download over the Amazon backbone from S3, that's what your delta would be. And that's going to be tiny. We're not talking about big values over there. Also to know, if you are using the container image support, we do a huge amount of caching behind the scenes to make that as efficient as possible. So so technically an increased package size does make cold start slightly slower, but it's only going to be slightly. And then remember, when your subsequent warm executions are going to happen, there's no cold start anyway. Cold starts are really only for a small percentage of invokes. So it's not the big thing you may think it is.
It's interesting you said that actually about the container image because I was quite surprised when I did these benchmarks, is that in some cases the container image is quite a lot faster than the zip, even though it's a bigger, you end up with a slightly more bloated thing because of the caching that you just talked about. It surprised me. That's all.
Yeah, I did a talk at reInvent all about how Lambda works under the hood, SVS 404. We go into lovely, excruciating detail all about how the cache works, and it is pretty
It's a
cool.
fantastic talk. Go watch
Yeah.
it.
Thank you, James. Yeah, and just then, your previous comments about some things aren't and aren't supported by AWS. Subarish, thanks for joining us via LinkedIn. Do you then recommend using .NET Lambda functions with native AOT in production at this point in time?
So one way I will answer that question is if you are doing anything asynchronous, kind of what you were saying actually, Julian, if you're reading off an SQS queue or you're doing anything like that, the performance, the performance benefit of native AOT is at cold start. If you're doing something asynchronous, that's kind of irrelevant. You might want to use .NET 7, but native AOT in production for something asynchronous, there's probably not the value in introducing that complexity of deployment, complexity of build, some of the features that aren't supported. So for asynchronous things, I'd say no. So British .NET 7, yes.
Unless
Native
you, I
AOT,
suppose, if you are very cautious on cost and you're at very high usage, where that cost is going to make a material difference, then maybe that would be something to consider.
yeah, absolutely. Now, if you're building APIs, and you've got really low latency requirements with a really spiky workload. So there's a project I worked on before AWS, and the requirements were double digit, really low triple digit millisecond latency, but with an incredibly spiky workload. So there was a lot of cold starts, a disproportionate number of cold starts. If you're in the situation I was in then, I probably would have really looked at native AOT, just to give that really low latency, unpredictable workloads. Yes, I would have looked at it then. As Julian said, the percentage of cold starts that actually happen in production, that's probably what you need to be looking at, because you do introduce some additional complications with native AOT. I realise I've not really answered the question there. Yes,
but I mean,
you
are recommending.
If I had really low, I'd ensure that I had really good test coverage on integration tests, like I said, to ensure that the data that was going out was expected, that the messages were being published, the data was being persisted. I'd do all that. But yeah, I would really look at it.
So I suppose everything would be great supported in production, but it's actually going to be the AOT stuff that Microsoft doesn't support. It's not a Lambda thing; it's a .NET thing. So you're talking about the ASP.NET stuff, which is not supported, and then you just got to be careful with your trimming, because that's what's not going to work. And the trimming is the AOT functionality. That's not a Lambda specific thing. That is a .NET specific thing. If you were doing this on a in a container or on an EC2 instance, and we're using trimming, it would be the same kind of thing. So just do your testing.
Yeah, no, that's a really good point. Yeah, if you were running this on EC2 or as you were function, that anywhere you're running this native AOT, you'd have them same problems because it's trimming. It's not the Lambda itself. Sorry.
Yeah. Okay. No, that's fine. Yeah, it's just to separate the what would be what a customer's concerns would be between the Lambda part of it and the .NET part of it. Yeah. I mean, there is SSH 2000, Lambda uses .NET, Amazon.com uses .NET, and Amazon Web Services uses .NET with a question mark. I'm not quite sure what you're asking, but just internally, AWS uses .NET is huge in AWS. So yeah, never think that because we're Amazon slides somehow we're not using .NET. The fact that we're doing .NET 7 and .NET on Lambda works extremely well. So I'm not quite sure what your question was, or you were trying to make some other point. I don't know.
Yeah, there was a whole track at reInvent. There's a whole bunch of talks on YouTube. There was a .NET track this year at reInvent.
Exactly.
I think the
huge
first
amount
time,
of stuff going on. And Oxbro, thank you so much. That's SVS 404. That's the link over there. Appreciate it. Yeah. So high performance.
Yes, so just to close out, I think let's just look at what the numbers look like. So this repo is where we do all the benchmarking for all .NET. So there's a whole range of things. You've got .NET Core 3.1, .NET 6, .NET 7, and various different things in between. How we do this benchmarking, just for absolute clarity, is we first ran AWS Lambda Power Tuning. If you're not familiar with Lambda Power Tuning, that's something that you can run. You can deploy it into your account, run it against your Lambda functions, and it gives you this really cool graph of cost versus performance, and you can kind of optimize for the sweet spot that you need. So we chose a gig of memory because that provided, as you can see from the graph, the lowest cost with a reasonably good performance still. And then what we do is we hit this API with 100 requests a second for 10 minutes. So that's how we generate these numbers. And then we have some CloudWatch log insights queries we can use to split out the code starts and the percentiles and all of that good stuff.
James,
So
is this all in the GitHub repo? Is that
this is all in the GitHub
okay?
repo.
So
Yes.
I will link and I did put the AWS Power Tuner, Lambda Power Tuner. I have put that in the link in the chat as well. So also here's the GitHub link so you can follow along.
Awesome. Thank you, Julian. So if we just kind of level set with what .NET 6 was, let's see if I can make this slightly bigger without all the formatting going weird. So if we take standard .NET 6 Lambda function with the managed runtime, they're the kind of numbers we're getting at cold start and warm start. So, you've got a P50 of 800 milliseconds right up to P99s and maxes of 1.4, 1.6 seconds. So, relatively slow cold starts. Warm starts are pretty consistent across the board, to be honest, even with native AOT. .NET is fast. Once it's warm, it's fast. It always has been. If we then compare that to .NET 7 and we look at native AOT, .NET 7 on x86, we look at that number there, we're talking P50. I don't know how quick you are at maths, Julian. Is that about 60%?
So what have we gone down from? We've gone from, what is it, just under a second, 900 milliseconds. Okay, so 800 milliseconds down to 372 milliseconds. Let's call it half. It's 800 to 400.
Yeah. so at P50 we've got 50% performance increase. If we look at some of the the bigger numbers, the max invocation time there, 1.6 seconds.
Half as well, yeah.
Native AOT, pretty much half. So we've seen between 50 and 70% performance increase at cold start. As you can see with the warm start, the numbers are, however you're running .NET, like I said, these warm start numbers stay pretty consistent, really, about 5, 6, 7 milliseconds sometimes. Excuse me. So the other thing I benchmarked recently was around running ASP.NET on Lambda. So if we look at running ASP.NET on Lambda previously with .NET 6, and this is running an entire API within Lambda, we've got at least a second. Best case, we've got a second. The code start times seem pretty consistent in this case, but we're talking a second of startup. And for most APIs, that's probably going to be pretty too slow for users. Flip this over to native AOT. So we've got here the native AOT minimal API on x86. I will say it again. I said it before. Microsoft do not officially support this. So if you encounter problems with doing this with native AOT, that's potentially a Microsoft. It's going to be a Microsoft thing. They are looking at supporting that for .NET 8. But again, if we look at the cold start time for native AOT with a full API, again, we've got just 50% almost across the board. Maybe not up at some of these higher numbers, but we've still seen quite a big performance impact on using native AOT. Now, what I will point out, just to kind of finish this off, is if we flip over to Go now. So keep these numbers in your head for a second. So we've got 300 milliseconds, 370, 430, 580. If we look at Go now, we look at the same numbers for Go. We've got pretty comparable performance at cold start to Go, TypeScript, Python. One of the common things that I get when I speak to people about .NET is cold starts are too slow. .NET's really slow. It's not fast enough. With native AOT, we're now looking at similar numbers to Go on some of the static languages like Python and TypeScript. I know Java are having these similar celebrations with snap start, so it's compiled languages across the board.
Yes, I mean, Go is one of the languages that is super duper fast to, super duper fast cold starts, a compiled binary. So yeah, compiled binary for .NET is, pretty comparable to Go, which is very impressive. And that's not using anything like snap start or, obviously provision concurrency would eliminate the cold start. But yeah, fantastic. That's great benchmarks. Well done for putting them all together.
Yeah, awesome. Thanks.
Two quick questions as well. We did get one about the ARM64 compiler. No packages exist with this ID. Anything quickly to look at? I know this is probably putting you on the spot to try and troubleshoot that. Well, thanks, Barak, for asking. Let's see if we can have a quick look.
Not off the top of my head, no.
Okay.
If you could ping me on Twitter or LinkedIn, but I can have a look at that. That's absolutely fine.
And then Subarish just came back with a question about web APIs do need to be converted to Lambdas behind API Gateway. Which approach do you recommend? Opening to refactoring and breaking down them into multiple Lambda functions. Either option is going to work. The fact it's not going to be a lot of code changes to get them working in .NET from Lambda. You've obviously got an event object, which is slightly different formatting, but that's literally just wrangling a different JSON object around. And then whether you run a whole bunch of Lambda functions via API routes within a single Lambda function, it's probably the equivalent to your lift and shift, the easiest way to start. But then as you want to go ahead, you probably want to start looking at refactoring into multiple Lambda functions, specifically if they have either performance requirements. Remember, this is synchronous, so you want to load less to have a faster performance. So if there are more things you can trim, it's going to be faster. And also from a security perspective, you're going to have different Lambda functions, maybe reading and writing from different databases. You don't have to have everything into one function.
Yep. If I could just add very quickly, Julian, if the API you're looking to move, Sabarish, is not doing anything with kind of state, like in memory state, because obviously Lambda doesn't really persist state across all the execution environments. In a lot of cases that I've seen working with people, it is almost as simple as adding this Amazon Lambda ASP.NET Core Server package and then just configuring Lambda hosting. And it will just run on Lambda, unless you're doing any crazy stuff where you've got SQL databases behind the scene that you might not need to manage the load against. It can be lift and shift to Lambda with the tooling is available to do that.
Well, thank you everybody for your questions. Anything last, James?
No, thank you for having me again.
Well, just before we do say goodbye, let's just do a shout out for the next show, January the 17th. We are going to be talking about Amazon managed workflows for Apache Airflow, which has an acronym of AMWAA, which is the joke is like, it's awesome. So you want to do that at scale. This was a reInvent talk, which wasn't recorded. So John Jackson's going to be joining next week to talk about that as well. Also remember, when you're building serverless applications, we've got patterns, and for step functions we've got workflows, and we've got cool little snippets all on serverlessland.com. That's what the s12d.com brings down. It's just a short link. Don't start it alone. There's loads of code out there that you can build your serverless applications, and this is all hosted on serverlessland.com. And there's a whole new section also on serverlessland.com all about building event-driven architectures. So if you did anything at reInvent and you saw Werner's keynote, huge big section, half an hour or 40 minutes talking about all asynchronicity and event-driven applications. If you want to understand what that is, head over to serverlessland.com and you can find out all about it. Well, James, thanks so much for joining us today. A pleasure to get your wisdom on .NET and particularly .NET 7 and high performance. And so, yeah, if you want to get hold of us on Twitter or via LinkedIn with any further questions, more than happy to. And yeah, thanks for joining us on Serverless Office Hours. And James, thanks for joining us. Really good.